Alors, nous avons le plaisir de recevoir maintenant Naama Geva-Zatorsky, professeur à la faculté de médecine du Technion, qui a mis au point cette année, en pleine crise pandémique, un test rapide et révolutionnaire de détection du Covid-19 qui permet de diminuer la vitesse de propagation du virus et de prévenir évidemment les chaînes d'infection. Un test salivaire que Naama va maintenant nous présenter et nous lui poserons les questions à l'issue de sa présentation. À tout à l'heure.
Hi, I'm Naama Geva-Zatorsky from the Rappaport Faculty of Medicine of the Technion. I opened my lab about 4 years ago, and we're studying the good bacteria and viruses that live in and on us, how they complement our immune system, and how can we harness them for our health. During the first lockdown, our lab was shut down. We found ourselves biologists at home while a virus is running around ruling the world. We couldn't bear this feeling, and we had many brainstormings of our lab trying to think, how can we help? This is most of my lab in this picture. And in one of our brainstorming, together with Shai Kaplan and Asaf Rotem from Boston, we came up with an idea to develop a method that can detect the virus directly from human samples and can provide results fairly quickly and in a simple manner. So the idea is a PCR reaction, exactly like the tests that we perform at the hospital. However, this is from saliva, non-invasive. It is performed in one temperature. So at the hospital, we also detect the nucleic acid of the virus by amplifying the nucleic acid of the virus. In the hospital, we need to extract the RNA, and we need to run it on a specialized professional machine. Here, we're using a specific enzyme and the reaction mix that enables the same reaction or a very similar reaction that also detects the nucleic acid of the virus, but in one temperature. Very simple, very easy to use. No prior professional experience is required, and at very low cost. I mentioned that when we thought about this idea, I immediately called Michal Powell, Professor Powell from Rambam, asked her if she thinks this is a good idea, and if they would like at Rambam to collaborate with us to test it on human samples. And Michal was extremely supportive and thought that it's an important need. And with her and Moran Schwarzworth-Cohen, we started working on actual human samples. I'll also mention that the Technion was locked, as I mentioned before, and I actually had to write to Kobi Rubinstein to ask him if he thinks this is a valid idea to open my lab. And his reply was that it sounds like a crazy idea, but sometimes crazy ideas succeed. So why not open your lab and run? So this is the reaction itself. We spit to a tube. The reaction is performed at one temperature. And the reaction mix from pink becomes yellow if the virus is present. In the reaction mix, an amplification reaction occurs. So we add primers, which are small DNA fragments specific to the nucleic acid of the virus. They detect the nucleic acid, and with the enzyme, they amplify this nucleic acid. It's a molecular reaction that detects the molecular nucleic acid of the virus. When the amplification occurs, protons are released. These protons reduce the pH of the reaction mix, and that turns the reaction mix from pink to yellow. We opened actually a startup company together with the Technion. The Technion was extremely supportive throughout, from the beginning, as I mentioned, and also by helping us to open this startup. And the reason to open the startup was to implement it to the population. And as I mentioned, it was with close collaboration with Rambam. This is how it looks. So these are the patient samples that we tested at the beginning. Pink is the T equals 0, the beginning of the reaction. Your reaction will remain pink if you have no virus there. And if the virus is present, it will turn from pink to yellow. We tested it on several hundreds of samples at Rambam. We got 0 false positives and 94% true positives. So the detection sensitivity is 94%. And it's very specific to this SARS-CoV-2 virus. We tested also several other viruses with this setting and we didn't detect anything. But I would mention that it is a platform. So with these small DNA fragments, with these primers, we can apply it to other viruses, to other bacteria. We can perform a multiplex reaction where you have one tube for SARS-CoV-2, another tube for influenza, another tube for salmonella, or many other diseases or viruses, bacteria that you're interested to detect. So at this point, it's highly specific, but it can be applied. I also mentioned that it can be applied to the virus while it evolves. So at this point, we can detect all the mutations that are now known to be present in the world. But if the virus will evolve and create mutations that will not be detected with our primers, we can very easily design new primers. It's very cheap and very fast and detect the new evolved virus. And this is how it looks. I'm holding there a pink tube and a yellow tube. We are thinking that this is, and we are getting support that this can be applicable to hospitals as a first triage. It can be applicable to airports, airlines, to schools, as it's non-invasive and very easy, and also as self-use at home. It can be either used one by one or in clinics as a lab, a very simple lab that can be also on site as a high throughput, like 96, 384, or even several hundreds plates at once. I don't know if I mentioned, but the reaction itself takes between 30 to 40 minutes. So it's not a minute reaction, not a reaction by seconds, but it's highly specific, highly sensitive, and 30 minutes is kind of, you wake up, you spit, take your coffee, and before you need to go out of home, you know your result. A couple of weeks ago, we got a CE, European CE mark, so we're approved in Europe. And we also signed with Africa. So at this point in Europe and Africa, we are approved and working there. Our first big case study was at the Technion. The Technion, as I mentioned, was extremely supportive, and this was a clinical trial that we received a Helsinki approval for. At the Technion, we sought to test all the workers and students that either live here or come in and out every day. They actually had to come to this point of care, which is just in one of the buildings here, to scan the code in order to approve that they agree to be part of this clinical trial. And this is our president, Professor Uri Sevan, scanning the code. Then to spit to a tube. Each person got his own barcode, which was a very unique number. And this tube was sent to our startup, to our lab, and tested over there. Very simple, no need for a real huge sophisticated lab, just a heating machine. And after 40 minutes, we got the results. The people who tested themselves, because we took several at once, had to wait a couple hours until they received the results. And they received the results on their phone. So this is in Hebrew, but the green means negative. A second use case that we performed was at the singing contest in Israel, where we actually taught them how to perform the reaction, and they did it themselves. So all the singers and performers came there, spit, they performed the test, and they say here that they were happy to hug each other after they know that they are negative. And the idea is either to perform it at home or as a lab on a chip, which we're working right now in collaboration with Professor Moran Berkovich here from the Technion. For the home test, we are working with Professor Ezri Tarazi here, that also from the Technion, that is, he's designing a very easy to use tube for this test. This can be performed already actually at home by a very simple heating machine that costs less than $30 and is reusable, and each test a couple dollars, and very easy to interpret the results. And there is an app, as I mentioned, that can show that you are the person that is testing yourself. So here in the picture, some of my team that was part of this extreme study. Dr. Oren First, with whom we opened the startup company. Dr. First was faculty at Yale, and now he's an entrepreneur, and it's really amazing to work with him. And our team, which includes Christopher Mason, Moran Berkovich, who I mentioned, Noam Shomron, and Ezra Tarazi. This is also one of our huge experiments that we performed with Mafat, the Ministry of Defense, who from the beginning really adopted us and helped us a lot throughout. We flew with them to India with a huge delegation and performed this huge study where we collected 5,000 saliva samples. And with these samples, we could test and improve our method. That's how we know that it's really 94% sensitive, 0 false positives, and 100% specificity. We published both in peer-reviewed scientific journals, and we're also on the news in Israel and also in France in the I24 news channel. Received good feedback. We're now in Europe and in Africa. And I really would like to thank the team, my lab team. I'll show in a moment a few pictures from our adventure. Michal Powell from Rambam and Moran Schwarzwald-Cohen from Rambam, and all the team, Shai and the staff who helped us initiate it. Also Rich and Nathan supported us, especially at the beginning, which was crucial. Michal Chavos from Meir and Danny King, and who also brainstormed with us and supported, and my lab, mostly the students listed here, but really the whole lab. And these are pictures from our adventure. So it was really the Zoom here is with Rich Roberts, who is a Nobel laureate, with whom we consulted at the beginning. It's us in the Corona lab at Rambam, Moran's lab. Really, we worked day and night. We're like, oops, it's sunset. Oops, it's sunrise. It was like we didn't know day and night. It was crazy. And then suddenly it's here at the bottom, but suddenly it's just over here. But suddenly the day after, we see ourselves in the news, in the news of Israel. So really unbelievable. These is our contact details, and I really would like to thank you for inviting me here and for listening, and happy to answer questions.
Hi, Naama.
Hello.
Hi, nice to see you.
Great to see you.
Thank you very much for this presentation. Thank you for being with us. So we have one first question for you, Naama. Could you tell what is the difference between your test and two other rapid tests?
Yeah, great question. So thanks a lot for this opportunity to present here. I'm very honored. So the difference, it depends to which. So compared to the hospital test, it is also a molecular test. Our test is a molecular test, similar to the hospital test. It's a PCR, which means a polymerase chain reaction, which means it amplifies the nucleic acid of the virus. Other rapid tests, many of them are testing antigens, which means proteins or molecules of the virus. So this is one main difference. Our test is very specific to this virus, and it can be easily changed. So if there is a variant, now a mutation, and I don't know, the test will not test the virus, it will not detect the virus anymore. It's very easy to adjust it and to identify the new mutated virus, the new variant. So that is one big advantage. So it detects when the virus is in us, it detects the nucleic acid of the virus, and it can be easily adjusted to changes in the virus and also to other viruses. We are now working on applying it to other viruses. It can also be applied to other bacteria, any nucleic acid, DNA or RNA.
Tell me, Naama, can your test detect the COVID variants, the mutants as well?
Yeah, so exactly. Up to now, we could detect the variants. But if we won't be able to detect the virus suddenly, then very quickly we can adjust the test to detect them. So it's very easy to change the way we detect the virus. So right now we can detect all the variants, but in the future, if there will be a variant that we won't be able to detect, we can very easily and quickly, like in a matter of days, adjust to the new variant.
Very nice. Also, are you being commercialized in Europe?
Yes. So in Europe, we actually got this CE mark, and I think about a month ago, and it's really great. We're open to work with anyone who is interested. We did sign with Italy with Mos Franco Papa, and happy to work in other areas in Europe. We did get the CE mark, which is really huge it was very good.
Very good. Thank you very much, Naama. Thank you
Thank
for
you.
coming. We see you
Thank
soon. Bye-bye.
Yes.
Thanks,
Hope to see
Naama.
you in Israel. Thank you.
Bye.
Bye-bye.